Okay, here we go. Recording. Yeah, it looks like okay, so voice is working, displays are working. So I'm John Reagan with boardbrains.net and Ulshe AI, Ulshe, ULSHE.ai. And what I'm bringing today is our first Rust-based CLI. This is a prototype. Initially, we're going to make this non-Rust. It's going to all be mict. It's all going to be compiled in mict, and it's going to run on its own kernel. It's going to be an interesting endeavor. But in order to get there, first thing you need to do is make sure you can properly transact with the system. So in this case, I've already made a language, an initial language set, and we've got strict typing. Actually, when I was running it through Rust, I found that Rust was a little stricter, so I had to go in and make some changes. So there's more work to be done there. There's a lot of work to be done in system calls and things like that still. However, using Rust gives us a good safe environment for prototyping and testing, and then we can develop the other components that we need to make the more lower level system calls and system interaction happen. So right now I've got you're seeing on here a MDO. This is our mic data object structure. Basically, what kind of type? This is a test. This is an array. This is the dictionary array and things like that. This MDO had no iterate, check, or transform stages in it, so these come back as just empty array sets. From there, I went ahead and started the Rust cargo run, which loads up our Genesis prototype shell. Here you can see that I have the OS loaded, and basically we load the module, right? Load the transfer transaction MDO. This is basically a tiny little application. From there, we can set the sender balance to 100, which I did here. It responds in setting the balance in the system, in the program. Here, then we execute the MDO transaction functions. So we've set the variable. Now we're executing the function set, right? And so you can see here, executing MDO transaction, fulfilling context requirements. And this makes sense when you read our mict Genlang doc specification, language specification, because you understand it loads context, it then goes through and iterates through things, verifies, and then initiates a change. So all of that is self-contained within the actual data object itself. In this case, it is an application that is all self-contained. It runs on a single engine that we've made for this in Rust, and eventually it'll be just its own MDO engine. So here we have it, input received, receiver balance is 50, input required for the transfer amount, I put in 50. And so then we got the IPC response, right? 100, final sender balance is a float for 50, right? And then just to check to make sure that the command's listed, I ran a help command, and it does. We load the file path, state, the key type and value. So it sets the global world state. So that sets our variables up. Execute whatever the MDO you want to execute on those said variables are. And then we can list the MDOs and the world state. So this will be interesting. I haven't done the list yet. I'm kind of excited. So down here, I wanted to test it again. So I ran it with the same thing, 100. And then I did the MDO. And this time I changed up the receiver balance to 20 and the transfer amount to 10, just to make sure that it did calculate things correctly. And it does calculate them correctly. I have that here. So let's go ahead and we'll list. And you'll see down here in the corner, we have our list, loaded MDOs, or the MDO transfer transaction, and the world state currently is the sender's balance is afloat at $100. So What happens here is this is a single instance, right? So this $90 doesn't end up update. It's only updated in this instance. It's not updated like a database yet. So the next stage is, after expanding the CLI to handle a range of system calls and begin to interact with the hardware directly, is to set up a database system based on the MDOs, an MDO spec, along with some other components that will allow for a full-fledged operating system to be run on the MIC data object specifications and the Genlang language specifications. So it all looks good. It's all working. It's very secure. Anything you state, anything you claim has to be essentially verified and then cleaned up kind of in the check stage. So it's kind of foolproof almost. So you just type exit and get back to the main terminal. Boom. It's actually kind of fun. I like it. I want to play this a little more. I'm going to make some different MDOs that do some different things. But even beyond this Genesis CLI, our other tool, the Logic Archaeologist, allows me to take C and C++ code and convert it to a mixed standard, right? Which gives me the variables, it gives me the iterations, it gives me the constraints, and then it gives me the context changes that occur at the end, the transform stage. From there, I can actually take and reconstruct that all as MDOs. So I can take current code, construct it to this newer code, make it essentially more secure and foolproof, and then either create that same code, so like a C++ or something from the MDOs, or do what I'm doing now, which is just build a new type of system out of the MDOs. So again, this is the Genesis OS prototype shell, real basic demo, but it does work, it does calculate, it executes, and the interactions are pretty flawless at this point. So it's looking good. More to come.